Hey Geometry, today we're going to look at symmetry. This is from section 9.5. Sorry, in the last section I labeled that as 9.5, but that was actually 9.6, the dilation section. Symmetry, you guys probably been with us for a while, but we're going to think maybe in a slightly different way. So a figure has what we call line symmetry, or reflection symmetry if it can be reflected across a line so that the image coincides with the preimage. If we reflected this hard over that line, it would become, go right over top of itself. So the line of reflection also called the axis of symmetry, divides the figure into two congruent halves. So these two halves would be congruent to each other. A couple ways of thinking about that. So identifying some symmetry in these, state whether the object appears to have a line of symmetry, right? Yes or no. If so, copy the figure, draw all lines of symmetry, and state the number. We don't need to copy it, but we can draw in all these lines of symmetry. So this one, we've got a line of symmetry there. We could kind of do this with a bunch of these. So 1, 2, 3, 4. Okay. I kind of hit 4 of those stars. I can't keep continuing because that's going to end up being the same line as I already have. So I've got 4 stars, but this one's actually got some more. Be careful about this. We've got there as well, right? If we split these two halves into each other, so 5, 6, 7, and 8. So yes, this one has symmetry. It actually has 8 lines that we can do for it. The next one, identifying lines of symmetry here, so we could split this thing in half that way, and it would reflect onto itself. We could also split it in half that way. So we've got a yes 2 for that one. Here, there's no way of slicing that thing so that those sides are congruent so that it would reflect onto itself, so that one's a no. If it was an isosceles triangle, we could. If it was equilateral, we'd have even more, but no there. This shape, this B, we can slice this way into 2 congruent halves. So yes, as 1 line of symmetry. This one here, we could slice that way into 2 congruent halves that way. So there's 1, 2, but we could also go this way as well, 3 and 4. So that one is a yes, and it's got 4 lines of symmetry that we can do. And then finally the Ohio State flag. Yep, we can do one right there along it. So that is a yes 1. Oops. All right, so another type of symmetry, this one might be a little bit different to you, is rotational symmetry. So a figure has rotational symmetry, symmetry, or radial symmetry is another way of referring to that, if it can be rotated around a point by an angle greater than 0, so you have to actually rotate it, and less than 360. Any object, if you rotate it 360, is going to come back to itself. So some other angle between 0 and 360, not including those, so that the image coincides with the preimage. So we have a couple other things to go with this. The angle of rotational symmetry is the smallest angle through which the figure could be rotated to coincide with itself. The number of times the figure coincides with itself as it rotates through 360 degrees is called the order of the rotational symmetry. And the magnitude or angle of rotation is the smallest angle through which the figure can be rotated so that it maps onto itself. The order and magnitude of rotational symmetry are related by this relationship. So the magnitude is equal to 360 degrees divided by the order. So we can figure out that magnitude from the order, or vice versa. If you know the order, you can divide, find the magnitude. technically you could also solve this if you know the magnitude to figure out what the order is. All right, so state whether each of these figures has rotational symmetry. Right, yes or no. If so, copy that. You would have to copy it. Locate the center of symmetry and state the order and magnitude of the symmetry. So this one, is there a point where we could rotate this around? Might kind of look like it, but not quite, because of the way that those, I don't know, like this line on the left stops there, and this one over on the right, like it doesn't quite, have any rotational symmetry. So that one's a no. This one, however, I have that image. If I rotate this to there, it looks like the exact same. And if I rotate it there, it's the exact same. So we have, so we're going to say yes. The center of rotational symmetry is right there. The order, so the order is, basically the number of times that it coincides with itself as it rotates through C60. So you do count, I mean, you can think of it either way. You do count 0 or 360. So we do count this orientation. So that's 1, 2, and then 3. It looks the same. So the order is 3. And then the magnitude is, and we can divide this, or you could figure it out, but it's basically 360 degrees divided by 3. And so that is going to be 120 degrees. And so our magnitude is going to be 120. All right, the next one. So can we rotate this thing? So it'd be right around this point here in the middle. And yeah, if we look at it that way, it should look the exact same when we rotate it that way, if it's been, printed properly. So it does have just 1 and then 2 before we get back to our full 360 where it looks like itself. So that's a yes. Order is, order is 2. The magnitude is, and we have to rotate this thing 180 degrees, or 360 divided by 2 would give us 180. So we can get it that way. This one, we just rotate around that point, so it's got this parallelogram going, slanting to the left. Boom, same exact thing. So this is basically the same exact answer. Yes, order is 2, and then the magnitude is 180 degrees. This next one, got a little like X in a circle, so I didn't show up super well. If we rotate it around that, it looks like the X, like the X-Men symbol there. So that's 1, 2, 3, 4, and then we're back to the beginning. So we count those 4. So yes, the order is 4, and the magnitude is 90 degrees. So if we took the 360 divided by 4, you could divide that up if you wanted to, but it was always a 90-degree rotation. This one, it's never going to look exactly like that as we rotate again. There's, it's never going to be that until we get back to here. So that is a no rotational symmetry, no order, no magnitude. All right, so more practice. Maybe practice on those if you can, see that last one. I guess good luck, but these other two you should be able to do. You can pause and try those on your own. This first one, you might think, oh, it's kind of the same, and to some degree it is, but not, because of the way that this is like shaded. That's not actually the same here. This yin yang symbol here. We got the dark side on the right. When we flip it here, we don't have that dark side on the right. So we'll say no as a bit of a technicality. If these were just lines drawn, then this one would have the order of 2 and the magnitude of 180 degrees. This one, so in this one, actually, sorry, we're supposed to look at both types of symmetry, lines of symmetry as well as rotational symmetry. So no lines, nothing on that one, so even though we could be if there was no shading. This one, so lines of symmetry, we could split it there. So we got 1, 2, but we could also slice these diagonals, 3, 4. So yes, it has 4 lines of symmetry, and then the rotational symmetry, we've got that as well. So if we rotate this 90 degrees. It looks the exact same, 90, 90, 90. So we actually have 4 for our order, and then that magnitude or that angle is 90 degrees. This one, I mean, yeah, you can't quite tell what's going on with that one. But it's supposed to be like a soccer ball, I believe is what that image is supposed to be, and it does have it's supposed to be there's these 5 like dark spots. So let me just put like dots on there, and I didn't draw that very well. So it's got like these 5 like dark spots, and yeah, it's got some symmetry. I think it should maybe look a little better than what I'm doing it. It should have 1, and then it does have like, so we could split it that way, but then it does have like 2, 3, 4, 5. So it's got 5 lines. So yes, 5 lines. And then when does it match up like itself? It's basically that same, like that 5. So order is 5. It does have rotational symmetry. It lines up and looks the same every each of those 5 times, which you can just think of like a dot being on the bottom, for instance. And so then if we do that, we get the 360 divided by 5 for the magnitude. And let me actually bust out the calculator so I don't screw that one up. 360 over 5 is 72 degrees. For that magnitude. So that's that one.